Alrighty, so you're either going to love this or you're going to hate this. If you remember limits from term 1, we evaluate a limit by plugging in 2 and we see what it equals. What that's going to tell us is what the graph is approaching as x gets closer and closer to 2. But sometimes we ran into some issues, like here. If I plug in 2, I'm going to get 0 in the numerator and 0 in the denominator. And when that happened, we decided that we needed to do not no work. My goodness. We needed to do more work. And for us, in this case, that meant we were going to factor. So I factored the denominator. That shouldn't be an h, that should be an x. That's cool. X approaches 2. That's going to give me x plus 2 times x minus 2. I reduce there, and I'm left with the limit as x approaches 2 of 1 over x plus 2. So if I plug 2 back in now, my limit equals 1/4. So this is how we did our limits at the beginning of first term. But what I'm going to do is show you a little trick. Now that we know how to do derivatives, check this out. So I take this, I plug in 2, and I get 0 over 0. So what I'm going to do now, the limit as x approaches 2, the derivative of x minus 2 is 1, and the derivative of x squared minus 4 is 2x. If I plug 2 in, I get 1/4. This is called L'Hopital's rule. L'Hopital's rule says if you plug in a value for a limit and you get an indeterminate form, our indeterminate forms that we're looking for are 0 over 0 or infinity over infinity. If you get one of those,
Pardon this interruption. Ms. Cluff, please call and contact the main office. Ms. Cluff, please contact the main office. Thank you.
if you get one of those indeterminate forms, what we're going to do is we're going to take the derivative of the numerator, the derivative of the denominator, and reevaluate that limit. So let's take a look at this example here. So if I evaluate my numerator by plugging in pi, that's x. Cosine of pi is -1. 1 plus -1 is 0. Then I'm going to evaluate my denominator, which is the sine of 2x. We're approaching pi. 2 pi, the sine of 2 pi is 0. So I have a 0 over 0. That's an indeterminate form. So using L'Hopital's rule, I'm going to take the derivative of the numerator. So the derivative of 1 is 0. The derivative of cosine of x is negative sine of x. In the denominator, the derivative of sine of 2x is cosine 2x times 2. Now I reevaluate by plugging in pi. Sine of pi is 0, and cosine of 2 pi is 1, times 2 is 0 over 2. So my limit is 0. And in this case, I wouldn't necessarily quickly know the algebra that I would have needed to simplify that. I probably could have done it, used some conjugates in there, some identities, but this is pretty easy. Now that we know we can take the derivative, that's a pretty easy approach. So again, you take the derivative of the numerator, take the derivative of the denominator, and this limit is equal to this limit. The values will give us the same thing. Same thing works if we get the indeterminate infinity over infinity, like we would see here. If I take the limit as x approaches infinity of x plus the natural log of x, well, that's going to be infinity plus infinity, which is infinity. Then the limit as x approaches infinity of x times the natural log of x, that's infinity times infinity, which is still infinity. So this indeterminate form is the infinity over infinity. So because that's one of my indeterminate forms, I'm going to apply L'Hopital's rule. So now I'm going to have the limit as x approaches infinity. Derivative of x is 1. The derivative of the natural log of x is 1 over x. In the denominator, I have a product rule. Left, d right, plus right, d left. And now,
Pardon this interruption. Mr. Moore, please call and contact the main office. Mr. Moore, please contact the main office. Also, Ms. Clough, please contact the main office. Ms. Clough, please contact the main office. Thank you.
sorry about that, guys. Okay, so now I'm ready to plug infinity back in. So I'm going to have, nope, we're plugging it in, so we're going to be okay here. We're going to have 1 plus 1 over infinity. That's going to give me 1 plus 0. 1 divided by infinity is 0, so 1 plus 0. Infinity times 1 over infinity, well, that's infinity times 0. And then I have infinity here. So we have 1 divided by infinity, which is 0. Not all of our limits are going to equal 0. So don't think that's true because my 2 examples are. All we got to do, take the derivative of the numerator, take the derivative of the denominator, and reevaluate that limit. Okay, if you got questions, let me know.